Hi, I am going to discuss about annual fabrication process. Annual fabrication process is used to design two transistors at a time by using single substrate. Like PVL process, we can design two transistors at a time. That is, assume that it is an P substrate. P substrate is having holes from the silicon substrate, and left side one transistor I am going to design source, gate, drain terminal. Right side one more transistor we need to design source and gate and drain terminal. One is NMOS or NPN transistor, one more is PMOS or PNP transistor we need to design. For example, if we take either NMOS or PMOS, only we can design single transistor by using single substrate. Even if we take N substrate or P substrate, we can design source and gate and drain terminals we can design. Only single transistors can be designed by using single substrate. Here within 2-3 steps we can explain about annual fabrication process. Here you can see this. To design annual fabrication process, so P substrate we need to take from the silicon substrate. This is P substrate which is having holes. So it is having holes, and oxidation process means total surface is covered with a SiO2 layer. This is common for all, and it gives the protection for the surface. Then diffuse the electrons because it is a holes material, P substrate. Then by heating this material we are diffusing electrons into P substrate. So this is the first step. Coming to the second step, to design gate terminals, deposit the polysilicon material which is acted as a gate. This is a gate terminal. I am assuming gate 1 for the left side transistor. This is the gate 2. Deposited gate terminals polysilicon material at the place of left and right transistors. So this is the second step. In the third step we are going to design left side transistor, that is source and drain terminals need to design. So for that, it is already P substrate having holes, so there is only one option. We can design NPN transistor. For that, by heating this material we are diffusing electrons into P substrate, mother substrate, by using mask. Mask is used to stop the UV rays where the diffusion is not required. So using this we are design here, and that is source and already gate we are designed in the previous step. Now drain terminals also designed. So left side transistor fabrication completed. Coming to the right side transistor, here in the annual we are going to design, that is one more transistor. For that, again here only one option is there. So if it is N substrate means we need to diffuse holes here. By heating this material we are diffusing holes into N substrate or else N well. So here by heating this material using mask we are diffused holes into N substrate. Now it is acted as a source, and it is acted as a gate, and it is acted as a drain terminal. So left side transistor design we are already designed, and right side transistors we are designed. These two transistors are used to design an inverter. So this is the inverter circuit. Two gates are interconnected. Across that we are giving input signal, and source and drain terminals are interconnected. Across that we are taking the output. This is an inverter fabrication process, but inverter operation anyhow we will discuss in inverter topic. So within a single step I will explain. Once again you can see this. We are taking one substrate, annual process. P substrate we need to take, P substrate which is having holes, and then here diffuse the electrons because it is a P substrate. So that's why diffuse the electrons, that is named as N well. Then to design gate terminals, deposit the polysilicon material at the middle of the substrate. Oxidation process common, I am not drawing here. So this is an gate terminals, gate 1, and this is one more gate for right side transistor. This is the one more gate. And coming to here, to design left side transistor, diffuse the electrons, because it is a p substrate, that's why it is here. We need to diffuse, we need to insert electrons into p substrate. Now we can see this NPN transistor we are designing in the left side, and right side again we need to diffuse the holes, because it is already electrons, it is having electrons. So only one option, we need to diffuse holes here, holes right side, holes here. So now we can see this PNP transistor we are designing. So like this we can design either 2 transistors at a time by using N-well process or P-well process. Thank you. Thanks for watching. If any suggestions, please send to me. Please subscribe my channel.